Hey everybody, welcome back. Hopefully yesterday's lesson went over smoothly. I didn't get any questions via email, so I'm guessing it was fine. Make sure that you're working on the homework, pretty shortly after you're watching the notes so it's all fresh in your mind. So yesterday we were looking at specifically our metric system and then how to convert within that metric system. And we saw how the conversions were pretty basic, moves of the decimal. Today we're going to be looking at a process called dimensional analysis. Now this is still converting like we were doing before, right? It's the process of converting, and we're converting from one unit of measure to another. Now again, within the metric system, you're multiplying or dividing by some power of 10. So all we saw was the decimal moving either to the left or to the right, depending on, what prefix you were moving to. But if you're in the standard system, remember the standard or English or customary system that we use here, we're not multiplying or dividing by a number that is a power of 10. So we're going to be multiplying or dividing by a number that is not a power of 10. So for instance, if you had a number of feet and you wanted to convert to inches, you're going to divide by 12 inches. Well, dividing by 12 isn't a move of the decimal, right? It's going to be some other quotient. So if we're going to be converting just within the standard system, or from metric to standard or standard to metric, the multiplying and dividing will be by numbers that aren't powers of 10. So if we're going to go from metric to standard, or standard to metric, or even just converting within the standard, it's not a simple move of the decimal to make the conversion. And so we're using this organizational process called dimensional analysis, and what we're specifically going to be multiplying and dividing by are called unit fractions. And unit fractions are the key. Okay, now it's helpful if you know a lot of these unit fractions, and you'll see what they look like in a second, but fortunately for you, you don't have to know them even when you're working on your assignments in MATLAB. The unit fractions are going to be provided for you, so you'll kind of have them to reference. Now keep in mind, when you take your quiz for this unit, you will also be provided any unit fractions that you need. The problems will look just like they're going to look on the note sheet, so don't worry about memorizing them, although I hope that many of them that you're going to see, you're going to know. Okay, so what is a unit fraction? A unit fraction is a fraction where the numerator and the denominator have equal amounts. So the amount that we have on the top and the amount that we have on the bottom are the same, but they're in different units. Okay, so for example, we could say 12 inches and 1 foot. Those are equal amounts. They're the same length, but one of the units is in inches and one of them is in feet. If we made a fraction out of this, we would call that a unit fraction. And it could be the other way. I could have said that there's 1 foot and 12 inches that are the same. It doesn't really matter. I just chose it that way. Okay, so that's an example of a unit fraction. Again, that's one that I'm hoping that you know. Or something like 1 hour is the same thing as 60 minutes, right? Those are equal amounts of time. They're just in different units. Or maybe like 4 cups is equal to 1 quart. Equal amounts, different units. Now those are all units of measure that are in our standard system. There are also going to be unit fractions that help us go from the metric to standard or vice versa. So maybe something like, I don't know, 1 inch, which is a standard unit, is the same thing as 2.54 centimeters, which is a metric unit. Now that's approximate, it's not exactly 2.54, but it's pretty close, and that would be a unit fraction that we could use to go from a standard to a metric or vice versa. Or maybe something like, there's 3.28-ish feet in 1 meter. Okay, so these are all examples of unit fractions. Again, the top of the fraction, the bottom of the fraction, they contain equal amounts, like equal lengths or equal volumes or equal times, but the units are different. And those are going to be the key to making conversions. So when we make a conversion, let me go to my scratch paper for a second here. I'm going to start with something that we know. If I said to take 36 inches and convert that 36 inches to feet, I'm hoping that we know how to do this. So when we're working here. We know 36, or we know how to, I'm hoping we know how to convert 36 inches to feet, because we know that 1 foot has 12 inches, right? And I just wrote that one down for you on the note sheet. But we would take the 36 inches and just divide by 12 inches, and we'd say, okay, that's got to be 3 feet, right? Now that's an easy one because we're familiar with this process and we've done this before and we have a concept of what 36 inches look like. But there won't always be units that you're familiar with, so I want to show you a process, the dimensional analysis process that we can use to work this, whether we understand the units or not, okay? So what we want to do, technically, when we're using the unit fraction, we're going to start with 36 inches, and we're multiplying by a unit fraction, and it's the unit fraction that has the units that we are trying to get rid of and the units that we're trying to get to. So the units we're trying to get rid of are inches, the units we're trying to get to are feet, and the unit fraction for that compares, or that makes a ratio out of inches and feet, was the one we said a second ago, that there's 12 inches in 1 foot. So this is the unit fraction that we want to multiply by, because again, it contains the units that we have and the units that we're trying to get to. So I have to multiply this 36 inches that I'm starting with by this unit fraction. Now when we multiply it, what we want is for the 12 inches to be on the bottom of the fraction and for the 1 feet to be on the top. Because this side, which we can also make a fraction, it all becomes one giant fraction, right? When we multiply it straight across the top, it's straight across the bottom. So all of this belongs together on the top, and all of this belongs together on the bottom. So if we put the 12 inches here, because there's an inches in the top and the bottom, those units will cancel, and then we're left with the units that we were trying to get to, okay? So technically we're taking 36 inches, which is over 1, and then we're multiplying by a unit fraction, which was 1 foot equal to 12 inches. And we want the units that we're trying to cancel to be diagonal from each other, right? One on the top, one on the bottom, so that they cancel. And then what happens is, again, we multiply straight across the top here. So straight across here would give us 36 feet. And then on the bottom here, 1 times 12 would give us 12. No units there. And then 36 divided by 12 is our 3 feet. Okay? Now, I don't want to say I'm lazy, but I don't like having to put all the parentheses in here. So when I do this process, I just make a little t, but it's going to represent the same thing where this part of the t is a fraction, this part of the t is another fraction. Okay, so in the first part, I'm going to put in what I'm given. So I was given 36 inches, and that was it. So I'm just going to put a 1 in that open spot. And then the unit fraction is going to go in the next spot. So we said we were going to use 1 foot and 12 inches. And this is just an organizational tool, okay? It means the same thing that we had here. I just use a T instead of putting all those parentheses in. It helps me organize it and make sure I have things corresponding with the tops and bottoms of the fractions. But we're doing the same thing where inches still cancel. We're still going to multiply straight across here to get 36 feet. We're still going to multiply straight across here to make that 12, and then we're going to divide the result to get 3 feet. Okay, so that's sort of how the process is going to look. Now again, that seems like a lot more work than we need. If you know how to go from inches to feet and you can just divide by 12, fine. But it won't always be that clear because there will be some units that we're not so familiar with. Okay, so this is a process we can use to help us through some of those unfamiliar situations. So I want to make a little t table, and if you don't like that option, if you just want to write your fractions with parentheses, you can. But what that t represents is the product of fractions. And we're going to put the given measurement, whatever we're starting with, that's going to go in our first column. So the one I showed you, we started with 36 inches. We're going to put that in the first column, right? This would be column 1. And then we're going to put the connecting unit fraction. Remember, we want it to have the units that we start with and the units that we're trying to get to in the second column. So here in column 2 is where I put the 12 inches in 1 foot. And then we make sure that the units that you want to cancel are on opposite sides of the fraction. So we want inches to be 1 on the top, 1 on the bottom, so they go away. And then that leaves you the units that you were trying to get to. And then it's multiply straight across the top, multiply straight across the bottom. So that gave us the 36 and the 12. So we multiply straight across, and then we divide those products. So multiply straight across and then divide the 1 fraction that's remaining. And the only units that are remaining are the ones that should be remaining are the ones that you wanted to begin with, which in this case was the feet. Okay, let me get rid of all this. I'm ready to try this out. Again, sometimes it's going to be simple. If you don't need this whole process and you can see what's going on, then don't use it. But if you're not sure, I think this process will be helpful. Okay? Oops. Go away, calculator. All right, so page 2. Here we go. So converting 30 inches to feet. And notice this is our unit fraction that we're going to be using. It's given to you. It will be given to you when you're working on your assignments in Math Lab. It will be given to you when you take a quiz or something like this ended up in the final. So while you should know there's 1 foot or 12 inches in 1 foot, it's going to be given to you so that you know what you're using. Okay? So 30 inches to feet. I'm going to make a little t out of this, which just represents fraction 1 and fraction 2. Okay? So we're given 30 inches. So 30 inches is going to go here. Since that's all we're given, I'm just going to put a 1 in that blank spot. And then we're trying to get to feet. And here's where we have to put in column 2, the unit fraction. So I want to put the 12 inches here. And I want to put the 1 foot here. That way I can get these inches to cancel. And then we're going to multiply straight across the top. So 30 times 1 is going to give me 30. And there's still units of feet left there. And then on the bottom, 1 times 12 is 12. And now my last step is just to divide. Now what is 30 divided by 12? Go to my calculator here. So 30 divided by 12 is going to be 2.5. So we're looking at 2.5 feet. And again, if you could do that without the process, totally fine. But there's how you use the process. So 30 inches is equivalent to 2.5 feet. Okay? Let's try that again. This time we're trying to convert 26 ounces to pounds. So I'm going to make a little t out of this. I'm starting with 26 ounces. I'm going to put that here and just a little 1 in that missing spot. And I'm trying to convert to pounds. And I know from my unit fraction here that 1 pound is equal to 16 ounces. So I'm going to put the 16 ounces here and the 1 pound here, because in this form my ounces will cancel and I'll be left with pounds, which was the goal. Okay, so here we multiply straight across the top. 26 times 1 is 26. Multiply straight across the bottom. 1 times, oh sorry, this is 26 pounds here. And then 1 times 16 on the bottom is 16, and then it's just division. What is 26 divided by 16? 26 divided by 16 is 1.625, or if you prefer the reduced fraction, you could make it 13/8, but I'm going to make it a decimal. 1.625, this is 1.625 pounds. So 26 ounces is the same thing as 1.625 pounds. Okay, now number 3 is going to be a little more than what we had going on here, and you can see there are 2 unit fractions given, but we're trying to convert from 60 miles per hour to feet per minute. So we're trying to make 2 changes here. Not only are we trying to go from miles to feet, but we're also trying to go from hours to minutes. So that's 2 conversions, which means we're going to have to use at least 2 unit fractions, and that's why we're given the 2 different amounts here. So I'm going to start with a t. And it was 60 miles per hour. In this case, let me scooch this over. 60 miles per hour, okay? In this case, it's 60 miles per 1 hour. So we're going to use this divide line here like the word per, okay? So 60 miles in 1 hour is our given units. And we're trying to convert to feet per minute. So you're going to do one at a time. Let's say first we want to go from miles, that should be mi. Let's say we want to go first from miles to feet. And let me color code this so you can see. If we want to go from miles to feet, then we're going to use our miles and feet unit fraction. I want to get rid of the miles, so I'm going to put the 1 mile here and the 5,280 feet here. I don't know if you knew there were 5,280 feet in a mile, but that is the case. And since these are opposite, those miles would cancel, and now our units are in feet. Okay, now that was only one of our conversions. I need to make another spot here to go from hours to minutes. Hours to minutes. So hours to minutes, again, I'm going to try to color code this for you. Hours here to minutes here. So we're going to use the unit fraction that contains hours and minutes. And I want to get rid of hours. Since hours is on the bottom of the fraction here, it needs to be on the top of the fraction here. So we're going to put 1 hour and then 60 minutes. And since again the hours are across from each other in the fraction, those will cancel. And notice what we have left is feet per minute, which was the goal. So now it's a process of multiplying and dividing. So we multiply straight across the top. So we're looking at 60 times 5,280, which is 316,800. 316,800. And that was feet left on the top. And then on the bottom, 1 times 1 times 60 is 60 minutes. And now it's just a divide. What is that? 3,608, or 316,000, sorry, 800. We're going to divide that by the 60 that we had on the bottom, and we end up with 526.6 repeating. So this is 526, was that right? Yep, 0.6 repeating. And the units would be the feet per minute. That we were, oops, where did I go? Feet per minute. Okay, and there it is. So if we have to make 2 conversions, we're going to have to use at least 2 unit fractions. And again, you want to make sure that the units you're trying to get rid of are on opposite sides of that fraction. Okay, so the next one is pretty similar. Feel free to pause and give it a try. If not, I'm going to continue working, and you're welcome to do so as well. So we're trying to go from 8 cups per day to pints per year. So I'm going to start with 8 cups per day. That's my starting unit here. So 8 cups per day is in 8 cups 1 day. All right, so let's say, and we're trying to get to pints per year. Let's say that first we want to deal with this cups going to pints. Okay, according to our unit fraction, there's 2 cups and 1 pint. So I'm going to put 2 cups here and 1 pint here. And the reason the 2 cups went on the bottom is so that those units could cancel. Okay, now I need a second part of my table here. Now I need to go from days to years. And so we're going to use this unit fraction with days and years, and it's 365 days in 1 year. So the 365 days are going to go here, and the 1 year is going to go here again, days on the top, so that it cancels with the day that's on the bottom here. All right, now it's a process of multiplying and dividing. So on the top of the fraction, get rid of some of this, we have 8 times 365, which is 2,920. 2,920, and that unit left on the top is pints. On the bottom, 1 times 2 times 1 is 2, and that would be years. Now if we actually divide 2,920 by, sorry, my fat fingers sometimes have a hard time on that little keyboard. We get 1,460. So it's 1,460 pints per year. So pints per year. And there it is. Okay, now all of the conversions that we've made for these first 4 problems, those are conversions within the standard or English or US customary system. Inches and feet are standard units, ounces and pounds, miles, hours, feet, minutes, cups, pints, days, year, all well, days and years is uniform, but these are all standard units. What we're going to be looking at next are the ones that I don't think are as obvious, because we're going to be looking at going from something in our metric or something in our standard system to something metric or vice versa. So for example, number 4, cups is a standard unit, liters is a metric unit, but we use the same process. It's just that the unit fraction may not be something that we know. Okay, so let's see here. We want to go from 3.5 cups to liters. So I'm going to make my little T. I'm starting with 3.5 cups. And that's it. So I'm going to put a 1 here for that missing spot. And then we're trying to get to liters. I'm going to use my unit fraction. I'm trying to get rid of cups. So I'm going to put the 1 cup here and the 0.24 liters here so that the cups cancel. And then if I multiply across the top, let's see, we have 3.5 times 0.24, and that gives me 0.84. 0.84, that's liters, and the bottom is just a 1, which means we don't need it. So we're looking at 0.84 liters. And really, this should probably be an approximate. 1 cup is not exactly 0.24 liters. Notice the approximate or the squiggly equal here means it's as close as we can get to an estimate because there isn't an exact conversion. So let's say this is approximately 0.84 liters. Okay. All right, same thing is going on here. We have 58 ounces and we're trying to go to liters. Now notice that the unit fraction has milliliters. That's okay. We know how to handle that. I'll show you in just a second. So I'm starting with 58 ounces. So 58 ounces, that's it. So just a 1, that missing spot. And I know that 1 ounce is equal to 30 milliliters. So I can get rid of my ounces, and 58 times 30, I don't want to try to do any mental math and screw this up. It's 1,740 milliliters, and on the bottom is just 1. So we have 1,740 milliliters. Now, if it asked for milliliters, we could stop there, but it actually asked for liters. Well, we know how to go from milliliters to liters. That's what we looked at yesterday. Remember, King Henry died by drinking chocolate milk. If we want to convert from milliliters to our base, which is here, liters, then we would have to move 1, 2, 3 times this direction. So we're going to take my decimal and move it 1, 2, 3 times same direction. So this is going to be equal to 1.740 liters. Okay. Let's see, pounds to kilograms. This is kind of a useful one, 150 pounds. Let's see. Before I started teaching this stuff, I had no concept of how pounds and kilograms compared, but basically 1 kilogram is going to be about 2 pounds. It's close to that. So we're starting with 150 pounds here. So I'm going to put my 150 pounds over 1, that's all I have, and I'm trying to get to kilograms. So I know that 1 pound, 1 pound is approximately 0.45 kilograms. If I put that 1 pound here, then the pounds will cancel. So this is 150 times 0.45, so 67.5. So 67.5 kilograms is remaining. It's just 1 on the bottom. So again, I'm going to use the approximate because this is an approximate equivalence here, an approximate unit fraction. This is going to be about 67.5 kilograms. Okay. 7 has maybe a unit you haven't heard of before. I'm sure we've heard of acres. Acres are a standard or English or customary unit. It's basically square miles, like acres or square miles of land. In the metric system, they use hectares. Okay, it's a similar way to measure. It's similar to measuring how we measure acres, or what we would use to measure acres. Even if you have no concept of what that means, we have unit fractions to make our conversions here. So we're going to go from hectares to acres, and we're also going to go from, go to green here, hours to days. So we're going to need 2 unit fractions here. So let me start with what it starts with, 32 hectares per hour. So 32 hectares, 1 hour. 32 hectares per hour, looks like that. And let's maybe make the red jump first, from hectares to acres. So 1 acre is about 0.4 of a hectare. So I'm going to put 0.4 hectares here and then 1 acre here. That way the hectares cancel. And then we want to go from hours to days. So I'm going to use 24 hours. I'm going to put hours here and then 1 day here. Hours on the opposite side of the fraction make those cancel. And now it's multiplication and division. So on the top of the fraction, let's see, get rid of some of this. We have 32 times 24, which is 768. And the only unit that's remaining there is acres. And then on the bottom, 1 times 0.4 times 1 is just going to be 0.4, and the only unit remaining is days. So now we're going to divide 768. Let's divide by 0.4, and that gives us 1,920. So 1,920, this would be acres per day. Acres per day. And let me erase this again. This was approximate because the conversion from acres to hectares or vice versa is an approximation. So if, let's say, I don't know, you're a farmer and you're farming 32 hectares per hour, that would be equivalent approximately to farming 1,920 acres per day, or that was hectares per hour. Okay, so here's one again for you to try if you want to give it a shot. Feel free to pause and do that. Otherwise, let's work through this one here. We're converting $3.75 per kilogram to dollars per pound. Now this looks tricky. Might look like we're making two conversions here. So we've got $3.75 per 1 kilogram, and we're trying to convert that to dollars per pound. So we started with dollars and we're still ending with dollars. That's not a conversion. All we have to do is convert from kilograms to pounds. That's why we only have one unit fraction here. So I'm not messing with the dollars. I just got to get rid of the kilograms. So 0.45 kilograms in 1 pound. Kilograms across from each other makes those go away. And so multiplying on the top, 3.75 times 0.45 is 1.6875. 1.6875, and that dollar sign is still there. On the bottom, 1 times 1 is 1 pound, so this is going to be 1.6875. Wouldn't really make sense to keep all of that because it's money, so let's go ahead and round it. Let's say this is, again, approximately $1.69 per pound, or LB. No idea why pounds are abbreviated LB, but whatever. Okay. So I think all those are pretty straightforward. The next one we're going to look at is a little odd. Again, it's going to go from a standard, or from a metric to a standard unit, but we're looking at converting 570 cubic centimeters to cubic feet. So centimeters to feet would be just one conversion, but because it's cubic centimeters and cubic feet, we're going to have to be really careful on this one. So when it says 570 cubic centimeters, so 570 cubic centimeters means centimeters cubed. Now technically centimeters cubed means centimeters times centimeters times centimeters. So that's what we're starting with. Cubic centimeters means centimeters cubed, which means it's being multiplied by itself 3 times. So if I want to get to cubic feet, I'm going to have 3 feet being multiplied in there, right? Or I'm going to have to get rid of centimeters 3 times. So if I put in, for instance, the 30 centimeters and 1 foot only one time, it's only going to cross out 1. It's only going to cancel one of those. So I have to do it again, right? 1 foot and 30 centimeters again to make that cancel, and then a third time 1 foot is 30 centimeters again, so that third centimeters canceled. And now what am I left with? 1, 2, 3, so that's feet cubed. Okay, so on the top of the fraction, 570 times 1 times 1 is 570, but now it's feet cubed. On the bottom, 30 times 30 times 30, 30 to the 3rd power is 27,000. So 27,000. No units on the bottom, so we just need to divide 570. Oops. 570 divided by 27,000. And maybe if you like the fraction better, 19 over 900 would be fine. Otherwise, 0.021 and the 1 repeats. So 0.021 and the 1 repeats, feet cubed. Okay, I don't know if I put any of those in the homework where you're having to go from cubic or even square units, but if you see it, you're going to have to use your unit fraction multiple times to make them multiple